So we're deriving implicitly, meaning anytime we have some other letter than x, we're gonna, at the end, we're gonna say dy over dx, okay? So just as a reminder, this guy right here is product rule. So we're gonna write 1x times 1y. You don't need the 1, but I think it's gonna be helpful. What is the derivative of x squared? 2x. And then our product rule. Derive the x, which is 1, keep the y, plus keep the x. And when I derive the y, it is 1, right? But I also need to add on what else? dy over dx. And then what's the derivative of negative 3y? Minus 3 and dy over dx. And derivative of any constant is 0. So I'm going to do multiple things in one go. I know I need to go ahead and make this by itself. So I'm going to write dy over dx. And then I also know, according to algebra, I need to move this over to the other side and move the y to the other side, and that's by the opposite. And our opposite is minus 2x minus y divided by the coefficient, which is x minus 3. So we're almost there. What values can I plug in from the given? My x and y. So when I plug in my x and y, I get negative 2 times 2 minus the 1 all over 2 minus 3. We know our bottom is automatically negative 1, correct? What's on top? Negative 5. So that simplifies to what value? 5. Hopefully you did not miss this one. Number 12 is almost a freebie. So let's see why that is the case. Danielle, let's read number 12.
The number of gallons of water in storage tank at time t in minutes is multiplied W of t equals 25 minus t squared. So 0 is less than 2 over t is less than 8.5. At what rate in gallons per minute is the amount of water in the tank changing at time t equals 3 minutes?
Let's underline at what rate. Rate is our slope. Slope is our derivative. So if I take my W of t and I find the derivative, what is the derivative of 25 minus t squared? Negative 2t, very good. And then all I need to do is plug in what value of t? 3. So we have negative 2 times 3 is how many? 6. So ideally, this question should have been, I think more time should have been spent reading the question, but not answering. Okay, that alone is going to gain you 50 seconds, which is really nice. All right, number 13. Not 13. Is there a 13? Oh, there is a 13. Silly me. Okay, so we have our slope field. And this slope field is kind of mean because the trick I tell you guys by looking for 0 is not really nice. Because if you notice here, y, if y is 4, the whole thing is 0, right? And notice they kind of, this didn't change no matter what. So that's kind of mean. So I'm going to give you a little way to kind of go about this problem. When you're picking out a point, pick out a point that's guaranteed as a positive. Okay, so you can pick out 0, 1 is like slightly positive, right? You can also pick 0, 2 that I'm going to pick. I don't know why I chose that number. I just got lucky, okay? Same on the other one. You can choose to pick 0, negative 1, or for me, I just chose the other opposite, just because. Was that? Oh, that's actually a good point. So that would actually be up here. Silly me. And then, are you all okay if I just kind of go down here and say it's negative 2? Maybe? And it'll still be a very, very steep positive. So I'm going to look at this guy right here. When I plug in 0, 2, let's see what we're going to get. So we have my x is 0. And no matter what that number is, it's going to be some positive number over 4. And that's going to give us slope of what? Our slope is 0. And if you notice at this point, our slope is positive, correct? So I know I can knock that one out. Okay, let's plug in the next one. For this one, if I plug in, let's do the same one. Y is 2. 4 minus y is some positive number over 4. That's going to give us what? 1. So it's going to be positive, right? So that's a potential. Let's go on to part C then. Same value. When I do x times y, it is 0 times 2. Ooh. And when I plug in the other value, it's still positive over another positive. But because we have a 0, Isn't my slope 0 on this one? So we know my slope at 0, 2 is positive. It is not 0.
You made that below, please.
Move it up. Yep. The next one, if I take 2 all squared, it's going to be 4. And then 4 minus 2 is some positive. You can put in physical numbers too. That's completely up to you. And another positive. So we know our slope is what? Positive. So then I want to go ahead and pick out a different number. Let's pick out a number where it's going to be somewhere in a different quadrant. And I want to look at quadrant. Someone give me a number on this side.
Negative 2, 3.
Negative 2, 3. Could we actually use, okay, negative 2 up 3 right here?
Oh, I'm stupid. I forgot.
Should we use that number? Someone give me another number that's friendly. I will use ones, I would use zeros, and I will use whole numbers. 0, negative 2. Thank you. So when I use 0, negative 2 in here, we get negative, and we have another, not another, this is going to be positive because it's 4 minus a negative over a positive. That's going to give us a negative value. But we know by the slope field a while ago, if up there it was positive, right here was also positive, so we know B is going to be gone. And then go on to D. Let's just double check D, even though we know it's going to be positive. So we know that's going to be y all squared is 4. 4 minus that is still positive over a positive. So we know this one is going to be the best answer. So what's going to really get you on the slope field is picking out the right number, and then at some point you might get frustrated or you might get lucky, okay? But try to stay within the axes to make your numbers easier, because 1s and 2s and 0s are easy. All right, so 14 and 15, I did say if you have to guess, guess, right? I am still going to go over it for those of you guys that are hoping for a perfect score. Okay, let's look at number 14. Actually, let's do 15 first. 15 has a property that I believe we have never used, and that's why it is okay to guess, but I'm going to quick teach. Okay? Jessica, go ahead and read number 15. Okay, we're looking for something that is false. So let's start with the first one. The limit, it means approaching. So we're looking at f of x, that's g of x. So as I get to 1, from the left and the right, are we approaching a common number?
Yes.
Again, when it's approaching, it doesn't have to be shaded in. It is getting closer to. So we know this one does exist, and it says which is false. This is true. So I'm going to cross this off. The next one is looking at g of x. What number are we approaching on g of x? 2. So 2 from the left and 2 from the right. There is a jump. If there is a jump, it does not exist, correct?
Yes.
But then it's asking us which one is false. So the next one is going to involve some work. And this property, again, we have not used yet. So I'm going to look at C. Let's start by rewriting the C part out. And I'm going to go to C over here, rewrite. Limit as x approaches the 1. And I'm going to separate the limit from f of x to g of x. F of x times the limit as we approach the 1 from g of x plus 1. Now, this first part we're familiar with. So let's look at our graph. As we get to the 1 on the left, what number are we approaching?
0.
0, very good. It is going to 1 on the x, right? 0. This property, again, is something new. I can bring this to the front and say g of the limit as x approaches the 1 of x plus 1. What that means is, when I compute this guy over here, and I plug in the 1 into the x, what is that inside number going to end up in? So let's find g of 2 then. At g of 2, do I have anything at g of 2?
Yes.
At g of 2, we have some number, and that number is called a 1. I know that's open circle, because g of 2 means when x equals 2, what value of y do I get to? So really in the end, we have, I should write out 0 over here. So we have 0 times 1, and it does exist. And this one says it does not exist. So given that fact, let's practice this guy over here. So start by rewriting. Limit as x approaches a 1 of f of x plus 1 times the limit as x approaches a 1 of g of x. Now we know this guy over here already. Find g of 1, or where are we going when we approach 1? 1. So all that is 1. So I can bring the f out. So we have f of the limit as x approaches a 1 of the x plus 1. And we know when I plug in the x value of 1, all this is going to end up in what? F of 2?
Which is -2.
F of 2,
I mean,
f of 2 is -1. Yeah, some negative. And it does exist. Okay, as I go over number 14, and you're like, oh, this is quite annoying, it is okay to put your pencil down, okay? I'm not going to be mad about that.
Can you just start off with the correct answer?
Start off with the correct answer. Where's 14? 14 on the back here? Oh, okay, Holland, go ahead and read number 14, please.
The weight of a population of yeast is given by a differential function y, where y of t is measured in grams and t is measured in days. The weight of the yeast population increased according to the equation dy over dt equals ky, where k is a constant. At time t equals 0, the weight of the yeast population is 120 grams and is increasing at the rate of 24 grams per day. Which of the following is an expression for y of t?
So let's write out initial amount. We're starting with how much of the population? 120. And because I'm thinking ahead and at some point I need to figure out what the C value is, or the K value I mean, I'm just going to say if it's going up 24 per day, at day 0 is 120. That means at day 1 we're at where? 144. This is going to be for later when we plug in x comma y. So then I'm going to start by rewriting the function given. Put all the y's together and put the x's together, or by x's t's. So I'm going to move the t over to this side, dt, y on the bottom. So we have 1 over y dy is equal to k dt. And we know when we integrate, we should be very familiar. Integral of 1 over y is always what? Natural log of the what kind of number? Absolute value of the y. Very good. And I could put plus c here, but let's put it one time on the other side. Derivative of any constant is, it is kx. And I guess I'm going to change that to the x instead of t. Yeah, okay if I just write x instead of t? I like x is better. Plus c. And then we have the understood base. This is back in from like algebra 2 even. We have understood e. So when I drop and cross this, we get e to the power of kx plus c is equal to y. And isn't e some number? Yeah? Isn't c also some constant as well? So another way to write this out is the following. And if you need like a little review, I'll write something on the side. It is c e to the power of kx. Because e to the power of c became just some random constant. Are we okay with that? Not okay. So then let's do some algebra review. I'm going to go up here and say, when I had n squared plus 3, that was technically n squared times n to the power of 3. Is that right? So what I'm basically doing is I'm taking that and separating it and making one a constant times another exponent. Okay? So now we know the initial, the c value is the initial is 120. So I'm going to plug in y is equal to 120 e to the power of kx. And then we also know something else. When x equals 1, y equals how many? 144. So 144 is equal to 120. Since x equals 1, I'm just going to say e to the power of k. I guess k times 1. That might work out. So my goal is to solve for k. To solve for k, I'm going to go all the way over here. Y'all see why this takes forever? And it's okay to guess? So e to the power of k is equal to 144 divided by 120. And I want to make this even smaller. What is 144 and 120 both divisible by? So 144 divided by 12 is 12. 12 divided by, or 120 divided by 12 is 10. So it's about 1.4-ish. Well, not 1.4. Someone correct me. 1.2. Silly me. So I'm going to write out e to the power of k is equal to about 1.2. And we're gonna go even further. Back in pre-cal, if your variable was on the power, you'll have to do natural log on both sides. Do we all remember that? Okay? So I'm gonna do drop and cross. We have natural log of e. Oh, that's not, where did I put L? Of 1.2 is equal to k. Actually, that's not even needed. Let's kind of talk about this. You guys do know e value is 2.72? Is it 2.72 or 2.71? I forgot. E. Let me find e real quick. 2.72. So let's rewrite this guy. 2.72 to the power of k is equal to 1.2. So here's my question to you. First of all, looking at this, we know it's not C or D because the format right here. Guys in the front, I'm almost done. So if I have some big number, a bigger number to the power of something, that k has to be greater or less than 1. It has to be less than 1. K must be less than 1. And the only one that's got less than 1 power, that's 24, that's 1/5. B will be the best answer.
Yeah, if I feel